This is the Group H software demo for Lab 10. I'm Sharon Satish and my partner is Mohammed Amida, and this is the FIFO lab. So the purpose of the lab was to input 16 different 12-bit inputs into a FIFO, and then use a button to transfer that to a serializer, and then divide that into three 4-bit numbers in the serializer, and then send each of these 4-bit numbers to 3 different PWMs with a green LED, a red LED, and a blue LED, and then eventually make the RGB lights on the FPGA board display, and then also display the 3 numbers from the serializer onto the seg drive as well, and then display the 12-bit number onto the seg drive as well, the 12-bit input. So yeah, I'm just going to walk you through the FIFO code. So the FIFO code, obviously we have the data in, and we have parameters so that it's generic and can be adaptable for any situation. And then we have the read and write function, or the read and write variable. And then we have the data out, which is the output. And then we have these flags to tell whether it's full or empty, the FIFO. And then even to verify these flags, we have this conditional test. So if the pointers are equal to each other, if that's true, then that means it's empty. If not, then it's not empty. So now we begin to the clock. So we have 2 always statements. They're both coordinated with the positive edge of the clock. And then basically, if we want to write something, it will write into the memory, which is a 2D array here. We will write into the memory whatever we're inputting in here. And then to read it, that's where the output comes in. It basically makes the output equal to the read pointer index of the memory array. And then these indexes are set at the same time. So if the FIFO isn't empty and the read is turned on and the write is turned on, this can happen spontaneously as well because they're both if statements. So you could add one to the pointer and continuously just keep adding until it becomes full. And then so the data out mainly comes from the read function. And then this data out, in our case it's 11 to 0 data out right here, and this gets sent to the serializer, which uses always statement at either a push of a button or when the input changes or when the state changes here. And if the push button is 1, then that's where it serializes it and divides it into 3 different numbers of 4 bits each, and it goes to the different PWMs here. And then this is set so that we can verify that the case is correct here. And then now we go to the top file where everything is connected. So we have our clock manager, and then this clock manager wire, the clock out, is sent to a variety of different things. It's sent to the FIFO. It's also sent to the PWMs and the finite state machine as well. And this is to verify that there's a uniform clock, because if the clock is asynchronous, that could lead to a lot of different timing issues. And then so basically we start off with the clock, and then the FIFO generates this wire, and then this wire is connected here to the input here, and then the output of the serializer generates these three wires, and then these are all connected to the respective PWMs. And I named this wire seg7 seg display because we have to display these values in the 7-segment display. So this essentially takes out 2 birds with 1 stone, because this wire will establish all the connections here, but it will also connect to the 7-seg display here, so that it will make displaying the numbers much more simpler. So yeah, this is just an overall software demo of the FIFO lab.